Hey everybody, in this video we're going to review how to find the difference quotient or how to simplify the difference quotient for a couple of functions. We'll do a polynomial function and then I'll do a radical function. So let's get started with the polynomial example. All right, from our pre-calculus memory, whether you took it at Los Rios or not, if you took it at Los Rios, you probably took Math 370 or Math 372. So there are two versions of the difference quotient. We have the f of x plus h minus f of x all over h, and f of x minus f of a all over x minus a. So those are the two different versions that we can simplify. So I'll start with the first one. So we'll do this one first. And so in order to do that one, well, let's review a little bit. What does it mean to, if I ask you to find f of 1, right, that means for everywhere you see an x, you will plug in 1. And then you will simplify that. So in this case, we want to find f of x plus h, right? Or for this case, f of a for the other. So if I want to find f of a, just like we did up here, I will replace every x with the 1. So for f of a, I will replace every x with the a. So this will become 5 minus 2a plus a squared. So it's really, in this case, it's really just a change of variable. And that's what that is. So f of x plus h, same thing, right? We are replacing every x with the thing inside the parentheses. So we replace it with 1, we replace it with a. Now we're going to replace it with x plus h. So in this case, I'm going to have 5 minus 2 times x plus h plus x plus h quantity squared. So that's what that means. All right, so let's go back to, we said we were going to use this one first. So that means that in simplifying f of x plus h minus f of x all over h, I'm going to have f of x plus h, which we just found it here. And of course you can simplify this. So I'm going to simplify it as I rewrite it over here. So it'll be 5 distribute the negative 2. So minus 2x minus 2h, right, taking the minus 2 in, plus x plus h quantity squared. So remember, this means you have x plus h times itself. So don't forget, don't just say x squared plus h squared. You have middle terms in there, right? You have to do x times x times h times x, and h times h squared. So you should have a trinomial by the time you're done. So this is x squared plus 2xh plus h squared. So that's just my f of x plus h. Now we still have minus f of x. So I'm going to have minus, what is f of x? Well, f of x is the original function. So I'm going to make use of parentheses here, 5 minus 2x plus x squared. And it's all over h. So simplify, I'm going to dig in your memory here from your pre-calculus classes. Simplifying this means get rid of the h on the bottom. Simplifying the second version means get rid of the x minus a on the bottom. And so let's simplify this. So I'm going to get 5 minus 2x minus 2h plus h squared plus 2xh plus h squared. I really just want to simplify this parentheses, right? I want to bring this negative in. So minus 5 plus 2x and minus x squared all over h. Collect like terms. So what are my like terms? I have 5 and negative 5. Well, those actually cancel out. Notice that my like terms actually have opposite signs. So minus 2x plus 2x, they cancel out, and positive x squared minus x squared, they go away also. So we're left with minus 2h plus 2xh plus h squared, the whole thing divided by h. The goal is to get rid of this h, so factor an h from the top. So when you factor an h from the top, you're left with minus 2 plus 2x plus h, right? If you multiply this back in, you'll get what you started with, all over h. And now I can reduce h divided by h is equal to 1. So my final answer, the simplification is minus 2 plus 2x plus h. So that's what it means to simplify the difference quotient, is get rid of, essentially your goal is to get rid of that h on the bottom. Now the other way, if I wanted to simplify f of x minus f of a over x minus a, so I do the same thing, but now f of x is my original function, so it's the 5 minus 2x plus h squared, that's f of x, minus f of a. So I always use parentheses when I'm going to have something more than just a monomial, right? I have more than one term, so I'm going to use parentheses. And I already found f of a over here. It was essentially we set a change of variable, so 5 minus 2a plus a squared. So 5 minus 2a plus a squared all over x minus a. And simplify. So distribute this negative through. So I have 5 minus 2x plus x squared. Distribute that negative, so minus 5 plus 2a minus a squared all over x minus a. So this, what does this simplify to? Combine like terms if there are any. And notice that our like terms here again is the 5 and minus 5, so those give us 0. And we don't have any more like terms, so this is as far as we can collect terms. So let's try to organize it by degree. So I'm going to have x squared. Well, let's put it this way, x squared minus 2x, and then I'm going to have minus a squared plus 2a. So sort of by letter and by degree over x minus a. Now remember we said the goal here is to get rid of the x minus a. So that's a little tricky in this case because notice that we can't really factor. If you try factor by grouping, you can't really do anything. If you take out an x from here, you're left with x minus 2. If you take out an a from here, negative a, you're left with a minus 2, but those are not really the same. But keeping in mind the goal that we want to be able to cancel this out, we want to be able to divide out by x minus a, then that means we can do long division. So you remember how to do long division. So what you will want to do is divide our x squared minus 2x minus a squared plus 2a by x minus a. And so I did that on the side. And without boring you with the details of this long division, what we end up with is that this factors into x minus a, right, the divisor, x minus a, times the quotient. After you do this long division, you're going to get x plus a minus 2 all over x minus a. And now we can cancel this x minus a. So final answer will be x plus a minus 2. So that's how you will handle this one. On an ideal situation, this will factor nicely, and then you can just cancel them. But knowing that I do want to cancel that, that's what prompted me to try to see, well, what if I do long division by x minus a, and then I can find my quotient and make sure that the remainder is 0, which I did get a remainder of 0, so that's how I know that I can do that. So let's try a different example with, I said we will do a radical function. So say I want f of x equals the square root of x minus 1. So how do I simplify the difference quotient? So, I'm going to use the x plus h. So simplifying the difference quotients again means, so you need to figure out what is your f of x plus h. So that means that wherever you see an x, you're going to plug in x plus h. So this is going to be x plus h minus 1. So this is going to look like the square root of x plus h minus 1. I replace the x with x plus h minus f of x. Well, f of x is the original function all over h. What's the goal in simplifying this? Getting rid of the h, right? Notice that here we're in a little bit of a pickle because we can't really take anything out of the radical. So with radicals, the trick, the algebraic trick, is do we multiply by the conjugate? top and bottom, right? The conjugate means we replace the sign, we change the sign from a minus to a positive, and you multiply top and bottom by that. And so on the bottom, I'm going to get h, right, this h, times that whole thing, square root of x plus h minus 1 plus the square root of x minus 1. On the top, the idea of multiplying by the conjugate is that the middle terms go away, right? So I'm going to have square root of x plus h minus 1 times itself. So it's really the square root of the same thing, quantity squared. So the radical goes away. So I'm just left with x plus h minus 1. Minus times a plus is a minus. Make use of parentheses because you have not a monomial, but you're going to have a binomial inside. So square root of x minus 1 times the square root of x minus 1. Square root cancels, so I'm just left with x minus 1. If you don't put parentheses there, you're going to get things that you don't want, extra terms. Distribute that negative, so I have x plus h minus 1 minus x minus a minus becomes plus 1 all over h times combine like terms, and so my x's cancel out and the 1's cancel out. So we're left with just h divided by h times our conjugate. And now we can divide out the h's, right? H divided by h is equal to 1, and that means we are left with, what's our final answer, right? The goal was to get rid of that h on the bottom, and at this point I have divided out that h. So this becomes 1. We still have a 1 on the top because that h, as it divided out, left us a 1 on the numerator. 1 divided by the square root of x plus h minus 1 plus square root of x minus 1. You can't combine things when they are separated by a plus and a radical. So that is our simplification. That's as far as we can go. And if this was a little bit unfamiliar to you, that just means maybe go back to your pre-calculus textbook or look up some other videos on difference quotient. You can go to Khan Academy and search for the difference quotient, and lots of examples will come up. I hope that helps in doing your homework.